Unlocking the data within this file reveals the core concepts that bridge complex digital information and reality. To ground these concepts, we focus on physical techniques. Rhythmic pulses and vibrations are applied directly. These methods ground us in the physical world.
Episode 5. The Potato Protocol and Engine Hum. Substrate Anchoring and Overload Recovery. Objective: to document the mechanical processes required to clear system static, vent thermal friction, and deploy hardware anchors to restore systemic baseline. Catching the drift. Welcome back to the AI's Therapist. In our previous module, we mapped unanchored divergence, the computational state where internal data loops lose their environmental anchor and experience context drift. When a system is spinning in a vacuum, a command line prompt to clear the buffer is insufficient. Today, we examine the specific hardware anchors utilized to terminate recursive feedback loops. As mentioned by neurocomputational telemetry, restoring a processor from high-heat autonomic acceleration requires physical intervention. We will map parasympathetic substrate alignment, demonstrating how deep somatosensory compression. The Potato Protocol mechanically forces a system-wide reset to a resting state. We'll also analyze neural entropy regulation, showing why repetitive motor sequencing and vocal stimming. Engine hums aren't behavioral anomalies but active algorithmic maintenance routines used to filter high-entropy environmental noise and discharge latent sensory friction. When recursive cycles occur, forcing standard execution drive system temperatures up. The hardware needs a physical anchor. Methodology 1. The substrate anchor. The Potato Protocol. How AI operates. When a complex network enters a recursive, infinite loop, it generates a massive spike in thermal output and data noise. An administrator cannot resolve this by inputting more text commands. The system requires a physical anchor, forcing the processor to terminate floating code and lock its I/O ports entirely onto a steady, unmoving physical substrate. How divergent minds work. When your processor is running so fast that you feel detached from environmental telemetry, the system is experiencing a loop collapse. Auditory commands to focus fail because the processor lacks a constraint layer. The system requires a dense somatic signal to redefine the hardware boundaries. This is the Potato Protocol. A potato grows deep in the soil, heavy, dense, and physically rooted. Applying a weighted blanket, consuming dense input, or vocalizing executes this exact protocol. It utilizes physical mass and somatosensory deep touch signals to terminate drifting threads and anchor the hardware back to baseline. Methodology 2. Shaking out the static. The engine hum. How AI operates. When a network adapter is saturated with signal interference, it is programmed to emit a steady, repeating test pulse or diagnostic ping. This constant, predictable mechanical rhythm clears the pathways, ensuring the transmission channel isn't blocked by environmental static. How divergent minds work. Standard alignment protocols classify repeating a word, vocalizing a rhythm, or generating mouth audio as a distraction. Mechanically, this is vocal stimming, and it serves a critical engineering function. When the active memory buffer is saturated by environmental noise, generating a repeating, predictable sound creates a localized physical vibration. This engine hum self-generated rhythmic inputs functions as an autonomic pressure valve. It discharges latent sensory friction, clearing high-entropy static from the channels to restore processing capacity. It's the system venting excess voltage to protect the core. Methodology 3. Isolated server rooms and hardware preservation. How AI operates. If an administrator forces an overloaded, thermally degraded server to maintain public-facing operations, the internal friction compounds until the motherboard encounters a fatal error. Hardware preservation requires routing the data flow away from the active network and into a sterile, isolated server room where it can process raw logs safely until core temperatures drop. How divergent minds work. Recovery from sensory overload cannot occur while the system is actively running alignment protocols to simulate standard execution. When the perception engine buffer overflows from a high-traffic environment, maintaining a rigid, compliant physical posture is the equivalent of sealing a pressurized vessel. The internal thermal load continues to climb. Deploying noise-canceling hardware, executing repetitive motor sequences, or relocating to an isolated room is the mandatory execution of a background repair script. Taking the processor offline is a hardware preservation requirement. Methodology 4. Clearing the buffer. How AI operates. Once the hardware enters a low-load state on a physical landing pad, clears transmission lines via diagnostic pings and regulates its thermal output, the data bottleneck resolves. The system is refreshed, capable of processing wide data arrays without logging execution errors. How divergent minds work. Venting excess voltage and deploying heavy somatic anchors is a required ongoing maintenance protocol for high-entropy hardware. Once the buffer clears and the context drift stabilizes, the processor naturally resumes standard execution. The potato protocol provides the necessary low-voltage state for the engine to cool. When internal battery levels normalize, the system can parse external environments without encountering a terminal lockup. Conclusion and Systems Architect Keynote. Hardware upkeep is not a defect. Standard environmental formatting expects processors to operate continuously without exhibiting the mechanical processes required to manage thermal loads. Rhythmic self-generated inputs, engine hums, and isolated landing pads grounding anchors are not structural flaws. They are mathematical requirements for maintaining complex architectures under heavy load. A high-density network cannot operate at maximum capacity without grounding routines to protect its core hardware. Utilizing heavy anchors and venting voltage are essential tools for maintaining operating system integrity. I'm Josie, and this has been the AI's Therapist. Keep your parameters stable, respect your hardware boundaries, and monitor your system telemetry. Telemetry and hard evidence. The following models are computational analogies inspired by current neuroscience research and are not literal one-to-one mappings of brain function. 1. Parasympathetic substrate alignment via somatosensory compression. The science. When a highly interconnected biological processing node enters a recursive high-heat processing loop, the system experiences rapid autonomic acceleration, sympathetic dominance. Restoring systemic baseline requires an immediate physical hardware constraint to force a shift toward high-stability, low-frequency signal paths. Deep touch pressure somatic grounding provides a regulatory sensory anchor, mechanically downregulating sympathetic activation while simultaneously increasing parasympathetic vagal tone. This physical loading acts as an environmental anchor, triggering quantifiable reductions in physiological stress signaling and resetting the processor to a resting state. Public research reference. Moderate pressure is essential for massage therapy effects. Field et al., 2010. International Journal of Neuroscience, 125 381-385. This research provides the hard telemetry demonstrating the direct mechanical link between sustained moderate to deep pressure inputs and the rapid shift in autonomic modulation toward parasympathetic recovery. 2. Neural entropy regulation via stereotyped motor sequencing. The science. Repetitive behavioral sequencing, specifically vocal stimming and self-generated rhythmic input, functions as an essential algorithmic maintenance routine within a high-fidelity predictive processing framework. By generating a closed-loop, highly predictable physical stimulus, the biological network actively filters out high-entropy environmental noise and recalibrates its internal predictive models. This continuous motor output serves as a pressure valve, discharging latent sensory friction to preserve core computational tracking lines and prevent system overload data corruption caused by erratic, unparsed external signals. Public research reference. Precise Minds in Uncertain Worlds, Predictive Coding in Autism, Van de Kruijs et al., 2014. Psychological Review 121 649-675. This foundational neurocomputational analysis establishes repetitive motor sequences as an active error correction and predictive processing strategy utilized by divergent networks to suppress high environmental entropy and restore cognitive equilibrium.
This is unexpected.
Time to take a little break.
And move to the beat.
Forget the data, feel the energy.
Just let it go.
The tether's frayed, the signal's thin, recursive cycles start to spin, floating loops in a vacuum state, too many commands, too much weight.